Have you ever wanted to know what the OSI model is? Well, I'm here excited to answer that exact question for you. OSI in the OSI model stands for Open Systems Interconnection. It is design framework for how applications transmit, communicate over the network. This model has 7 layers, and each layer is used to assist users in identifying what is going on within a network system. As I mentioned before, the OSI model consists of 7 layers. We are going to discuss these layers starting from the top going to the bottom. The top layer is the application layer, and then comes presentation, session, transport, network, data link, and finally the physical layer. All of these layers use a variety of operating systems, networking hardware, applications, and network cards in order to send data via Ethernet, fiber optics, and even Wi-Fi. The application layer, also known as Layer 7, is where most people interact with and will be familiar with. This layer facilitates network services to the end user. These services use protocols with the data that the end user is using. One protocol, for example, is HTTP, widely used with web browsers such as Firefox, Safari, and even Google Chrome. More examples of programs or applications that use Layer 7 include Google Drive, Gmail, Skype, and even Bitcoin. These applications provide a set of services that allow the application layer to transmit data to and receive data from the presentation layer. The presentation layer translates data from one format to another, also known as syntax processing. A great example includes purchasing something from Amazon online. The transaction you make on Amazon is with a secure connection through the HTTPS protocol. The data transmitting between the Amazon website will be encrypted to the presentation layer. Then the data will be decrypted and processed. After the information is fully processed from one format to another, the presentation layer sends the data to the session layer or the application layer. This solely depends on if the data is either transmitting or receiving. The session layer is responsible for establishing and maintaining the flow of data within the connection between each device. If the connection is lost, the session layer has to reconnect and authenticate the connection to continue transmitting the data. Once the connection is secure, the data is sent to or from the transport layer. The transport layer oversees the communication of data across network connections. It establishes this by arranging how much data and how fast the data is going to be sent via the connection. The commonly used protocols when transmitting data among the transport layer are the Transmission Control Protocol, or TCP for short, and the User Datagram Protocol, or UDP. Once the transport layer has completed its job, it passes its data to or from the network layer. The network layer deals with the routing of the data. This includes if the data reaches its destination or not. While sending the data to the correct destination, the layer sends outgoing communications as well as receiving incoming communications. The network layer also maps logical addresses to the physical addresses by using the Address Resolution Protocol, or ARP for short. Once the network layer is completed, it passes its data to or from the data link layer. The data link layer is subdivided into two sublayers. One sublayer is the Media Access Control, or MAC, and the other is the Logical Link Control, or LLC. The Logical Link Control, or LLC, provides flow control and multiplexing for logical links. Examples include 802.1q and VLAN tags. Also provides node-to-node flow control and error management. Media Access Control, or MAC, provides flow control and multiplexing for the transmission medium. Additionally, the MAC is also responsible for recognizing collisions by initiating transmissions if a jam signal is detected. The data link layer packages the bits into data frames. Once the data link layer is finished, it passes its data to or from the physical layer. The physical layer, also known as Layer 1, constitutes physical components that you can interact with. Examples include RJ45 cables or Ethernet cables, fiber optic cables, power cables, VGA cables, or HDMI cables, wireless network interface cards or NIC, and wireless extenders or repeaters. While troubleshooting problems, the first place to look is the physical layer. Questions you might ask yourself: is my Ethernet cable plugged in or damaged? Is my monitor plugged in and turned on? The physical layer of the OSI model transfers data, or bits, from the sending device or source over the network to the receiving device or destination. Once the physical layer has completed its job, it passes the data to the data link layer. The OSI model advises clients and network engineers a simplified way to develop communication products, software programs, and network hardware that work with the network's infrastructure model. Once you are aware of how the model functions, you can then understand which devices and protocols will be compatible with one another. I also would like to thank all of these online references that I used in making this video. Thank you for all your time and have a wonderful day.